Hi everyone, let's solve the second question from today's biweekly contest, which is minimum operations to exceed threshold value 2, which is an extension to the first problem. So let's see what the problem is. You're given a zero indexed integer array nums and an integer k, right? Similar to the first problem. And here the operation they have changed, right? So the operation now is you have to take two smallest integer x and y from nums. And you have to remove these x and y from nums, correct? And you need to add minimum of xy into 2 plus maximum of x comma y anywhere in the array. Note that you can apply the described operation if nums contains at least two elements. See, what you have to do, inside the first question you only had to take one smallest element, remove it. That was the operation. Here the operation is you have to take two smallest integer, right, x and y from the nums array. Then you have to remove x and y both from nums. And instead of xy, what you have to put inside the array? You have to put minimum of xy, whichever is minimum, into 2 plus maximum of x comma y anywhere in the array. Alright, so let's see. So what we have to add? Minimum of x comma y into 2. Let me simply write here minimum of x comma y into 2. And you have to take maximum of x comma y. Alright, so let's see inside this array. What is the operation? Take the first two minimum values. See, we'll take 1, 2, 3, 10 and 11, right? I'm just writing in sorted order just to make things easy, right? We are not sorting it. We are just discussing what the problem is initially, right? So take first two smallest elements, right? So x is what? 1 and y, let's say, is 2, correct? After taking this, you have to remove this from the array. And what you have to add inside the array? Minimum of xy into 2. That is 2 plus maximum of xy, 2, which is 4. So simply add 4 inside the array. So what your array will become now? It will become 3, 4, 10, 11. I'm just writing in sorted order. I'm not doing anything. I'm just making you visualize it. Then again, what you have to do? You have to take the two smallest value. So this was one operation that you did, right? Now again, doing the operation, right, you have to tell the minimum number of operation needed so that all the elements of the array are greater than or equal to k. Similar to the first question, it's just that the operation is different, right? All right, so you'll take in the second operation. This is the first operation, second operation. Okay, wait. Inside the second operation, x is going to be 3, y is going to be 4. See, 4 has been added inside the array. It was not originally present, but after doing the first operation, 4 is going to be inside the array. So you'll take 3 and 4. Then what you have to do? You have to again calculate this, remove these two, right? After remove these two, what you have to add inside of the array? You have to add minimum of x comma y into 2, that is 6 plus, because 3 is minimum, into 2, maximum of x comma y, which is 4. So you'll add 10 inside the array. So you'll get 10, 10, 11. Now see, all the values inside this array are greater than or equal to k. That means we had to perform two operations, and these are the minimum number of operations that you have to perform. All right, so I hope you have understood the question, what we have to do inside the question, what the operation is. Now let's discuss the approach to solve this question, right? So here inside this question, you might be able to see that each time what we are trying to access are the two smallest elements inside of the nums array, correct? And also we have to do one thing, that is after we perform a particular operation, we have to push something inside the array, and that is this particular value, right? So this particular value, see inside this, right, you had 3, 10, and 11, and then you had to add 4, correct, which is greater than 3. So it is not necessarily going to be less than 1 and 2 or etc, nothing like that. It can be a value which can be greater than like all the value, or even the largest value of the array. So what you have to do is you have to take in account this value also, right, to do further operations, correct? So that simply implies that we have to take always two smallest elements, and we have to maintain the sorted order after each and every operation, correct? So if we initially sort this array and take the elements, correct, and after doing one operation sort the array, take the element, that will be a huge time complexity, right? So we can't do that. So instead of that, what can we do? See, so there is a data structure called priority queue that we can use, or heap, right? So in this case we'll use min heap because minimum values we want to get. So what is a heap data structure? So you must already be aware that inside of min heap, right, it is a tree structure. It is a binary tree, and the value at the root node is the least value among all the nodes inside the tree. So when you remove this, right, so again the next smallest value will occupy. So let's say we have 1 as the smallest, right? So let's say 2, 3, and so on you can have. Then as soon as you remove 1, right, you will take the next smallest value. This next smallest value can be present here also. Let's say it's 1. Okay, if it's 1, this one we had removed, so again it will form a structure where again you're going to get the root as the minimum value among all the nodes of the tree or the heap, right? So this is the heap data structure, correct? And this is the property of heap data structure. Now the reason it's sufficient is that this process of taking the minimum value again out of the tree and putting it at the root takes only log in time, right? So for that, so priority queue is implemented using a min heap. So priority queue is even better to understand. So in priority queue, what happens is everything is stored in priority. So if you're declaring min priority queue, then minimum value is going to be having the maximum priority. That means it will be present inside the front of the queue. So here, what will be the priority queue look before we perform any operation? This is what the priority queue will look like. So what you'll do, you'll take the first element out of the priority queue, store it somewhere. Let's say you store inside of X, then take the next element from the priority queue. So now this will become your front. Take this element as Y, correct? And remove it. Now you have these elements and perform the operation. After you perform the operation, you know what you're going to get. You are going to get 4. And that you have to put inside of the priority queue. So priority queue rearranges itself to give you the same thing as like a sorted order, right? So you're going to have 3, 4, 10, 11, right? And again, next, what you have to do, you have to take the first element of the priority queue, take it outside, so it will become 3 now, then remove it. Take then the next front element, so which is 4, y is equal to 4, and remove it, and then perform the operation and again push the value. So then the next value that going to push inside priority queue is 10. So again the priority queue will make itself in sorted order, right? And this takes log and time complexity only, this heapifying method, right? This is called heapify, right? Whenever we take the, we remove the first the root of the tree and we take the minimum value from the tree and put at the root. So this takes log and time complexity. So now let's discuss the approach, right? So we discuss what we are going to use. We are going to use min heap or priority queue, min priority queue. Now, what you have to do is first iterate inside the nums array and create this priority queue, right? We want this structure first, right? You don't have to sort do anything because priority queue is going to do it for you, right? So after you make the priority queue, you have to iterate in this priority queue until it's empty, correct? So you'll start iterating inside the priority queue, take the first element out. So there is a top function pq dot top. Let's say our priority queue is called pq, inside of which you are putting the values. So pq dot top returns you the front element of the priority queue, which is 1. So X will be this. Then simply pop this element from the priority queue. Then take Y as pq dot top, because now the next element, right, this 2 will become the top element. So you'll get 2 from here and simply do pq dot pop. So after you are done with taking the two smallest value or elements from the array, you have to, and you have also removed them, correct? So see, it's helping us to remove the values also, correct? Now what you have to do, you have to simply do a pq dot push, right? The element that you get after performing the operation, which is 4 in this case, right? So when you do pq dot push 4, it will rearrange itself to form this, instead of like, it will not push the value like this after or in the last or in the first place, right? It will insert it wherever it belongs in sorted order, correct? So this is the reason that we are going to use priority queue. So in this case, the time complexity will become n log n, because first you have to do, see, to make the priority queue, you have to iterate inside the nums array. So log n is the operation it takes for insertion in priority queue, and n because you are iterating in nums array to create this priority queue. So in total, you're going to consume n log n time complexity. And for iterating inside the priority queue, it's big of n only. So you can consider this, but overall time complexity will be reduced to n log n, and space complexity will be big of n, because you are going to make this priority queue. So I hope you have understood it. Let's quickly see the code for this problem. So here we are taking a min priority queue. So the syntax to declare a min priority queue in C++ is this. So here another catch is that I'm taking long here because what you can have in the integer values that are given to you is 10 raised power 9, right? If it's close to that and you try to multiply it with 2, right, it will exceed the integer limit, right? And it will give you integer overflow. So to avoid that, simply take a long priority queue, right? Store elements as long, and see, in C++ by default, if you simply pass this like this, right? See, if I'm only declaring priority queue long, I'm not passing these two, then I will be getting a max priority queue. To make it a min priority queue, right, you have to pass these two parameters also. So vector, and inside whatever value you are storing inside the priority queue, you have to pass. So in this case, you're storing long, right? Here also long, because the value that you're going to store inside the priority queue is long. So this is min priority queue. After declaring the min priority queue, also check that if the size is less than 2. If the size is less than 2, obviously we cannot take two small elements from the nums array. That means we cannot perform any operation at all. So return 0. Otherwise, simply iterate inside the nums array and create this priority queue, correct? So you have to push the array elements inside the priority queue. After you're done with that, also take the cnt variable in which you will be calculating the operation. Start iterating inside the priority queue and take the first value, smallest value from the priority queue, and simply check if the smallest value is greater than equal to k. That means we don't need to perform any operation, right? Like what is the use of performing that operation if the value is already greater than k, right? The smallest value inside the array. So that means break from this loop. That means you have performed number of operations that were required. Otherwise, make this pop operation, remove this x element from the array, or sorry, the priority queue, then take the next smallest element and take it inside the y variable, and then pop this also. And then you have to push what? As it is, that is written in the question, minimum of x comma y into 2 plus maximum of x comma y, and simply do cnt plus plus. Correct? So this is what you have to basically do. And after this whole thing, right, either your priority queue will become empty, or you will be falling onto this condition and you will be breaking out of this loop. So you will get inside of cnt variable the minimum required operations, so that at the end, after performing these operations, all elements of the array are greater than or equal to k. So this is how you have to basically solve it. I hope you've understood it.